Hi, third grade teachers. Today we are going to take a look at Unit 5, Two-Step Problems and Time. The purpose of this video is to provide an overview of the standards, intended pacing, and sample instructional strategies. In this portion of the video, we are going to review the AKS and Indicators of Achievement, or IOAs, for Unit 5. The AKS are the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. The AKS and IOAs may not be taught in their entirety the first time they appear on the instructional calendar. Some AKS and IOAs will appear multiple times throughout the year. In Chapter 2 of the video, we will look to see how the AKS and IOAs in this unit are paced in detail. Let's take a look at Unit 5, Two-Step Problems and Time. On these slides, you will see the three AKS and the IOAs that support the AKS within this unit. Just as a reminder, at the end of each AKS and IOA in parentheses, you will see that we have the state coding so that if you are looking up resources on the Georgia DOE website, you are able to find the IOA that is related to the GCPS IOA. Unit 5 is anchored in multi-step problems and time. When teaching 3G, our focus will be on multi-step problems using multiplication and division. As a reminder, multi-step problems include 2 or more steps in a problem. IOAs 2A and 2B are intentionally included in this unit because students are expected to solve multi-step problems involving all four operations: addition, subtraction, multiplication, and division. These IOAs support the operations of addition and subtraction. One thing to point out, when solving multi-step problems, your students will be engaging in the addition and subtraction tasks within 10,000. When solving multi-step problems, students are expected to use equations with a letter standing for the unknown quantity, as well as justify solutions using numbers, models, and words. Is represented down here in 2B as well. Let's take a look at AKS 5. With AKS 5, our focus is the concept of time. IOA 5B requires students to tell time to the nearest minute, as well as estimate time to the nearest 15 minutes or nearest quarter hour. They have to do this using an analog clock. IOA 5C requires students to solve elapsed time problems to the quarter hour, including the hour and half hour as well. The times presented in contexts are only on the hour, half hour, or quarter hour. This IOA also includes identifying AM or PM. 5G is an extension IOA for time. Just as a reminder, the extension IOAs are included to support the differentiated needs for students. As you can see, the word extension is bolded in parentheses to notify you that these are just that, extensions. These extensions are specific to Gwinnett County, and because of this, you will not find resources from the state of Georgia for this particular IOA, nor will extension IOAs be paced on the pacing guide. Chapter 2, Unit Pacing. Our pacing guide is closely aligned with the state pacing. With this being the first year of the new standards, we want to ensure we are following the expectations from the state. As a reminder, the pacing guide is an example intended to model how instruction of the AKS and IOAs in each unit may be facilitated, but teachers should design pacing to be responsive to the learning needs of their students. Let's head over to Ecom to locate our Q3 pacing guide, and we will take a look at how the AKS and IOAs have been paced out over the course of Unit 5. Welcome to Q3. Just as a reminder, in this box of our pacing guide, you will find the unit name, suggested pacing, as well as big ideas for this unit. The big ideas for this unit are pattern and algebraic reasoning, along with measurement and data reasoning. The name of the unit is Two-Step Problems and Time, and the suggested pacing is approximately 4 weeks. Below that box, you will find the AKS that we have reviewed in Chapter 1, along with the IOAs that support that AKS. Just as a reminder, the left column of the pacing guide lists the learning progression of the AKS and IOAs through the concrete, representational, and abstract strategies. The bullets indicate the learning objective or learning targets for the day, as well as suggested manipulatives. The right column of the pacing guide shows the intentional instructional resources that align to the intended learning objectives for each day of instruction. Some days you will see a task-based lesson, which is your full numeracy block that day, and other days you will see instructional resources linked for the numeracy components of traditional teacher lessons. You will also see resources from the Georgia DOE website, along with lessons from Georgia Reveal, our newly adopted resource. For example, in this box here, we have a traditional teacher-led lesson where all numeracy components are listed, but we also have one of our tasks from our new resource listed as a possible student task. We are starting Unit 5 with IOAs 3G, 2A, and 2B, which are anchored in multi-step problems using all 4 operations for approximately 7 days. This unit intentionally starts with representational and abstract learning phases because time has been spent in the concrete phase of learning when these IOAs were initially introduced in all of our previous units. The pacing of these units and these lessons is strategic as they follow a progression of working with operations. For example, the first 3 days of these IOAs are anchored in addition and subtraction, where students use efficient strategies such as expanded form equations, partial sums and or partial differences equations, as well as the algorithm for addition and subtraction. They use these strategies because they will be solving these multi-step problems using addition and subtraction within 10,000. Then our pacing shifts to working with multiplication and division while including addition and subtraction. Remember, the left column will guide your instruction with regards to learning targets, models to use, manipulatives to reference, and the learning progression for these IOAs. After multi-step instruction, we transition to time. The concept of time represents the remainder of Unit 5. The concept of time begins with IOA 5B, where students tell time to the nearest minute using an analog clock. They also estimate time to the nearest quarter hour, but as you can see in the left column of the pacing guide, The progression of estimation of time is represented here. They will begin estimating time to the hour and half hour, and then transition to estimating time to the quarter hour. After telling time to the nearest minute, we transition to IOA 5C. This IOA involves solving elapsed time problems. Students are required to solve 3 different types of elapsed time problems. They have to solve problems where they find the unknown end time, as well as finding the unknown elapsed time or the change of time, as well as finding the unknown start time. These problems all are anchored in the nearest quarter hour. That is where they find their elapsed time. They will be given a start time to the quarter hour, and the elapsed time will end on a quarter hour as well. These problems have been strategically paced as well as the intervals of time. Students will start problems where they are finding unknown end times to the nearest half hour, and then progress to finding to the change of time and unknown start times to the nearest quarter hour. Instruction for the concept of time is approximately 8 days. Chapter 3 of the video will highlight specific instructional strategies that will be utilized in this unit. You will see instructional videos dedicated to multi-step problems, telling time to the nearest minute, and elapsed time problems. Please refer to the Analyzing the Standards document, or ATS, for guidance on additional instructional strategies for each IOA. Hi, third grade teachers. Today we are going to talk through some instructional strategies for IOA 3G. IOA 3G requires students to solve multi-step problems using multiplication and division involving whole numbers to 100. It requires them to represent the problems using equations with a letter standing for the unknown quantity, as well as justifying their solutions using numbers, models, and words. I do want to point out multi-step problems, a couple of things. Multi-step problems are problems that require 2 or more steps, right? The other thing I do want to point out about this, even though this particular IOA states multiplication and division, multi-step problems your students will encounter those types of problems with addition and subtraction. And those numbers could go, because we add up to 10,000, if they encounter multi-step addition and subtraction problems, it is likely they will see numbers up to 10,000. But when we shift to multiplication and division here, for example, in some of our multi-step problems, our students will encounter multiplication with addition or multiplication with subtraction or vice versa with division. If that is the case where we are multiplying or dividing with addition and subtraction, those numbers will remain within 100. So I just wanted to make sure we talk that through. But today, what we're going to do, we're going to talk through a problem. The work of the problem is not as important as the bigger ideas of why our students struggle with solving multi-step problems. And that's what I want to spend our time talking about today. But we are going to anchor our thinking with Renee and her family taking a trip into the city to the city zoo by train. We are going to take a look at this problem. But like I said, first, I want to talk through why students struggle when solving multi-step problems. A couple of reasons. One reason, they may be using or relying on strategies that are no longer efficient or viable. One of those strategies might be the keyword strategy. The keyword strategy is not a viable strategy. And this is because there's several reasons this is true. The keyword strategy, if students are using it, it can be misleading, and the students may oftentimes use the keywords inappropriately. For example, if there was a problem that stated 4 jackets were left on the playground on Monday and 5 jackets were left on the playground on Tuesday, how many jackets were left on the playground Monday and Tuesday? If that is the problem they are required to solve, but they key in on that keyword left, they are going to subtract. So they are using those words inappropriately. The keyword strategy does not require sense making of our students. They don't have to make sense of the actions that are actually occurring in the problem. Oftentimes, some of our problems don't even have keywords, so they don't know how to tackle a problem when there are no keywords. So again, not a viable strategy. And then when students transition into a multi-step problem, it is very difficult using those keywords. But what is important for our students and will help their understanding of how to tackle these particular kinds of problems is understanding how the operations behave, how they work. And oftentimes students don't know what operations to use when solving multi-step problems. And that's because they don't understand the actions or the behaviors of the operations. I highly recommend taking time to have this conversation with your students while creating an anchor chart. This anchor chart, your students will refer to constantly. And I'm going to talk you through what this would look like. So I'm going to slide our problem out of the way right now. And what I want us to think through, if I were doing this with my students, and I have, I would have my anchor chart prepared up to this point. And with the focus question of what happens or what actions occur when we perform math operations. I go through each operation and identify what actions happen when we are adding numbers or subtracting numbers and multiplying them or dividing them. And I'm going to model that for you real quick with addition. So I would ask my kids, well, what happens when we add 2 numbers? I promise you, your kids are going to say, well, you add them. So you will have to tease that out a little bit more and say, well, what does it mean when we add the 2 numbers? And you are going to want to elicit from your students that when we add numbers, we can join groups. We can combine groups. We can also connect groups. And these are just some of the verbs I've heard when doing this in the past with students. But the bigger idea here, talk to them about, well, what size are the groups when we add them? And most often, the sets you're adding will be different sized numbers, different size sets. Now, your students will encounter adding doubles. That is one case where they will be adding the same number they will be adding the same number, okay? But for the most part, when we are adding, the groups are not equal groups. Okay, so you would continue this discussion with your students in regards to subtraction, multiplication, and division. And I have done that for us here. Gone ahead and just kind of filled this in. And we want to have a bigger conversation with our students about what is the same among the operations and what is different, so they can begin making these connections. I oftentimes start with addition and multiplication and think through, okay, what is the same about addition and multiplication? And from your recordings, hopefully they are going to see that the actions are the same, that we are combining sets when either we are adding or multiplying. I will come here and write the word combine so that students know with addition as well as multiplication, we are combining sets. Then I will shift over to subtraction and division and talk about, okay, so what's the same here, right? And hopefully the students will recognize that we're removing groups, we're separating groups. With subtraction, they do compare because when we compare groups, we are sets, we subtract them. That's the operation we perform. But the bigger idea here is recognizing that with subtraction and division, we are separating groups. And I just write the word separate here because that is a pretty visible action, an action that your students can visualize pretty easily. Then I get into talking about, okay, well, let's compare multiplication and division. And we go through and we talk about how their actions are totally different. We're joining groups in multiplication, we're removing groups here. But the thing that is the same is that when we are multiplying or dividing, we are doing this with equal groups. So I right across the bottom so that students recognize with multiplication and division, we are removing or separating equal groups, or we are combining equal groups. Then I have the same conversation about addition and subtraction, and it does not matter the order you have this in. Again, the actions are completely opposite of one another. Addition, we join groups, or subtraction, we remove groups or compare them. But what is the same is that now, again, most often you are removing groups that are not equal, okay? So I, right at the top, not equal groups, and be very transparent with your students about, yep, you know what, we will add some with our double stacks, and maybe you remove a set 10 minus 10, maybe you're subtracting the same set, but most often you're removing groups or joining groups that are not equal in size, okay? That is a tremendous conversation to have with your students. And then you model for your students how to make application of what's happening in a problem to the thinking we've done with our students. And I'm going to walk that through right now. And I do want to point out that we are not going to spend a lot of time talking about the strategies to solve this problem in regards to mathematics, because we have done that in previous IOAs and videos that we've talked through. Okay, so let's take a look back at our problem here with our operations behavior chart. And let's look at Renee's problem. Renee's family would like to visit the city zoo this summer. Her family takes the train to visit the zoo. The sign below shows information about the train schedule. Teachers at this point, as your kids engage in multi-step problems or any type of problem that has a table involved, it truly needs to be modeled how to analyze what's happening in the table and how to use the information that's in this. So walk through with your students the title, what is listed, what information is in the chart itself. For example, here, this is train fare. An adult ticket is $9. A child is $7 before really making sure they understand that when tables are presented and problems, they need to really understand the information that's in it. Okay. All right. So moving on to the rest of the problem, Renee has $100 to buy 4 adult tickets. So I can see that math movie in my head or visualize what's happening. I know I have to buy 4 adult tickets. I know adult tickets, they cost $9. So 4 tickets costing the same thing. And I'm using $100 to pay for it. Okay. I know all of that's going on before I even get to the question. And the question is asking me, how much money does Renee have after buying the tickets? Well, oftentimes your kids, they'll encounter struggles with problems because they just want to be what we call, quote, number grabbers. They will just grab the 2 numbers they see and add them because we like to add. It's easy to add instead of thinking through the actions that are actually happening here in our problem. But let's go ahead and think that through real quick using our operations chart here. So Renee has $100 to buy 4 adult tickets. All right. So I know I have to join these 4 adult tickets together first before I pay for them with my $100. So buying the 4 adult tickets, I know I'm going to combine them. So when I look at my chart, if I look at the combination, not separating them, so I know I'm not using addition or subtraction, I'm using either addition or subtraction and division, I'm sorry. I'm either using addition or multiplication because these two operations, I know I'm combining groups. But what's different first, or how I can denote between whether I'm using addition or multiplication, is knowing I have to buy 4 adult tickets. Each adult ticket costs $9. So I'm joining those 4 tickets, but they are equal groups. I have 4 equal groups of 9. All right. If it was addition, it would be an adult ticket, maybe 2 child tickets, and those are not equal groups that we are combining. So back to this. We have 4 adult tickets that cost $9 each. I am multiplying. My equation is going to be 4 groups of $9 is going to equal the cost of our tickets. And I'm going to use a T as the letter to represent the unknown. And teachers, as a side note, it's up to you how you want to help your students or suggest for your students to organize their work. Some students may come up with a system on their own. I usually just partition my paper into parts so I know which part I'm working on first, all right? So 4 times 9, depending on where your students are with their learning progression in regards to multiplication, depends on how they're going to solve it. They may draw 4 equal groups, right? Where they will possibly draw their 9 dots in each one. 6, 7, 8. I think that's 9. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9. 6, 7, 8, 9. They may do that. They may be at the point where they are leaning more into 9 plus 9 plus 9 plus 9. Somehow, either way, to get a total of $36. My hope is that their thinking with multiplication is becoming more efficient. They may just know 4 times 9 is 36, or they may use, hopefully they're applying those thinking strategies for multiplication. To solve 4 times 9, I can use the half and double strategy. And the reason I can use that is because my factor of 4 is even. That means I can half this number. Half of 4 is 2. So essentially what I'm doing is multiplying 2 times 9. And then we have to do that again, which is when it's written this way mathematically, this is the half and this will be the double. And I'll show you what I mean. So if we half 4 into 2, 2 times 9 is 18. So we have 18 over here again. So we have to double 18. So to do that, your kids may just join the 10s and the 1s and combine them. Some of them may be to the point where they are using their algorithm if they choose. 8 and 8 is 16. I'm going to put a 6 in the 1s place, and that 10 for the 16, I'm going to regroup it and move it to the 10s column. And now I have 3 10s. So I know there's a total of $36 that is the cost of our 4 adult tickets. All right. So not finished yet, because I go back to the problem model for the kids. Well, I know she paid for them with $100. That's something else I've got to think through and figure out how much money she has after buying the tickets. And again, there's no keyword here for our students to hone in on. They truly have to think through what is happening here. So I know that I have $100 and I have to remove or take away $36 from that $100. So if I go back to my operations chart, I know I'm separating or removing groups, either subtraction or division. Those are I'm going to use one of those 2 operations. Again, go back to, well, let's think about that. If I have $100 and I'm removing 36, they're not equal groups. So I'm not dividing that. I'm subtracting that because 136 are not the same. So I'm going to subtract, and my equation is going to be 100 minus $36. And I'm going to use M for money. That's how much money she has after. That letter represents that unknown quantity that I'm trying to figure out. Teachers, real quick, I do want to talk through with you an abstract thinking strategy known as the compensation strategy. It is beyond helpful to teach your kids how to use this strategy when dealing with subtraction with a whole bunch of zeros. And the compensation strategy, I'm going to rewrite this problem vertically so that I can solve it using the algorithm here. The compensation strategy allows us to adjust the numbers that I'm dealing with so that the problem becomes easier to work with. Okay. When you compensate or when you adjust these numbers, compensate for these numbers, you are essentially going to keep the same distance or difference between 100 and the number 100 and the number 36. So think of a number line keeping the same distance or the difference. Okay. So to use the compensation strategy, to make 100 a friendlier number, I'm going to remove 1, and that makes 100 now 99. But I have to do the same thing with 36. I have to remove 1. So I am going to remove 1, and that gives me 35. So I've kept the same distance or difference between these two numbers because I've compensated over here. I've compensated for them. And just talk it through with your kids. 9 ones minus 5 ones is 4 ones. 9 tens minus 3 tens is 6 tens. So my friend Renee has $64 after buying those tickets, right? Teachers, there is more information about the compensation strategy in the small group moves for addition and subtraction. If you want to learn more about it, go check it out there. There is also a boot camp movie for that as well, or video, sorry. And let's think through the big idea here with multi-step problems. Help your students out so that they understand what are the behaviors of the operations. Okay, have this conversation with your students. I promise it will help you in the long run, and more importantly, help your students. If you need more information about IOA 3G, please go check it out in the ATS for AKS 3. Hi, third grade teachers. We are going to talk through some instructional strategies for IOA 5B. This IOA requires students to tell and write time to the nearest minute. It also requires them to estimate time to the nearest 15 minutes or the quarter hour, that being quarter past, half past, quarter till, that language, and they have to do this using an analog clock. We are going to look at a problem involving Mr. Williams and his class heading to recess to think through this IOA. But before we do that, I want to talk through some of the tools we have to teach our kids how to tell time to the nearest minute and how to estimate time. All right, let's take a look at these two clocks that you have access to in your math kit. You have a Judy clock, and you also have a number line clock. The Judy clock does a tremendous job in connecting and showing the relationship between the hour hand, and the minute hand. And what I mean by that, for example, is, let me set this for 5 o'clock. As I progress the minute hand, move it through the hour, so does the hour hand. The hour hand moves as well in relationship to where the minute hand is within the hour. So you can see I'm not quite at half past the hour yet, nor is the hour hand quite in the middle between the 5 and the 6. But as I keep progressing and continue up this way, getting really close to the next hour, and you can see here that the hour hand is getting really close to the next hour as well. And when I do get to 6 o'clock, my hour hand is positioned correctly. Judy clock, great job showing that relationship between the hour and the minute hand. The other tool we have is our number line clock. Slide that up there. Our number line clock does a tremendous job in helping students make connections between a true number line and that a clock is nothing more than a number line. You can see the minutes are clearly denoted. They are also grouped in chunks of 5 minutes, okay? That benchmark of 5 for our students becomes important. Knowing how to skip count by 5s is a tremendous thing when telling time. One other thing you can see, you can manipulate the minute hand here as well. One of the strategies we start with is teaching students to skip count by groups of 5 and then change their count by increments of 1 to tell time to the nearest minute. Okay. One thing, I don't know if you've realized that when my clock was set at 3 o'clock and I am transitioning or moving my minute hand, counting around, it does come off. I'm going to show you that in a minute. The hour hand has not shifted. So again, this number line clock does a great job showing time to the nearest minute. And again, our Judy clock does a good job showing that relationship between the hour and the minute hand. But back to our number line clock real quick, you saw the minute hand pops off, which is awesome. The hour also the minutes also pop off. They are grouped, here they are, in groups of 5 minutes. And students can clearly make that connection between a number line, just as they've worked with since kindergarten, to more of a curved number line is all a clock is. One thing, if your students are struggling to tell time to the nearest minute, you may want to have them take the minute hand and truly find a designated point on our number line. For example, if I wanted to find where the point 29 is on our number line, I would have my students start skip counting by 5s until they get close without going over to find 29. So if 0 is here, 5, 10, 15, 20, 25. Well, I know if I jump another group of 5, that'd be 30. That's too much. So once I stop skip counting by 5s here, I can count by 1s, 26, 27, 28, 29. You can just, have them use their minute hand to point that out as well. That is a great way to use this if students are struggling to make that connection when the minutes are on here in a circular fashion. The other thing, you can use this clock as a one-handed clock, especially this helps with estimating time. Remember, you do have to manipulate the hour here. So if this is 1 o'clock, if you place the hour hand right at the seam here on the clock between the 1 and the 2, about what time is it? It's a great way to help students estimate time, and we will dig more into this in just a few minutes. All right. But the other thing, real quick, the hour hand comes off as well, and so do the hours. That's out of the way, and your students can hopefully make connections that, yes, the hours do denote that unit of time, the big numbers, the red numbers in this case, but it also denotes it's one group of 5 minutes. When the minute hand gets on the 2, that's 2 groups of 5 minutes, which is a total of 10 minutes. You could also make the connection to your clock facts multiplying by 5 if you choose to. But this is a great tool to help your students do that. Tell time to the nearest minute, and we're going to jump into that right now. All right, so let's take a look at this problem. All right. Mr. Williams looked at his watch and told his class that it was time to line up and go to recess. Okay, here's his clock. His watch. Your students will have to be able to tell time or read the time and as well as write the time in digital form as they work through our unit on time. It's important for students to understand that the hour is denoted before the colon and the minutes are denoted after the colon. Okay. I always like to help my kids understand that when they're dealing with units of time, the hour unit and the minute unit, because it helps them set the time by dealing with just those individual units first. So Let's look at part A here. So we know what time Mr. Williams's watch says. It says it's 1:46. The first thing we are being asked to do is figure out what does the time on the classroom clock look like. We are going to use our number line clock here. And the first thing I tell my kids, going back to what are the different units of time, hour is the one they have to deal with first. I always have them set the hour first. So we know this is 1 o'clock. I am going to position my clock so that it shows 1 o'clock. Awesome. The next thing I'm going to do is we've got to figure out where the minutes are. That means we have to count each minute around the clock until we get to 46. Okay. Your students also need to understand that an hour is a total of 60 minutes. That will also help with their estimation of time as we get into that in a minute. But let's find where point 46 is, or minute 46 is on our clock. Again, we are going to skip count by groups of 5 because our minutes have been grouped that way. I'm going to start with my minute hand here and skip count 5, 10, 15, 20, 25, 30, 35, 40, 45. Now, as I get here, I really want to point out to my kids, well, I can't make another jump of 5 because that would put me at 50, and I know 50 is more than 46. So let me go back to 45, and now I have to change my counting sequence to just ones. So if I'm at 45, 1 more than 45 is 46. So this is what the time should show, or how the hand should look on Mr. Williams's classroom clock. Okay. Your Judy clock also does the same thing. You give me just a second, sorry. I'm going to go back and show my students if they have this clock. Yep. First thing you're going to do is identify the hour, which we have done here. It is 1 o'clock. And now I'm going to find where 46 minutes is on my clock. I know 46 is getting pretty close to 60, so it's going to definitely be past 30. It's going to be on this half of the clock. You can skip count by 5, 5, 10, 15, 20, 25, 30, 35, 40, 45. Change my counting sequence to 1:46, and that is 1:46. I'll hold it right there so it's like that. Okay, so that is what the classroom clock will look like. This is that concrete phase. Your students will start learning to tell time to the nearest minute. In the representational phase, your students will be asked to label blank clock faces to represent these times. So they will need to know where the placement of the hour hand is as well as the minute hand. And I'm glad I said that because as I look back here at my number line clock, again, remember what I said? Judy clock does a great job showing that relationship between the minute hand and the hour hand. Well, the number line clock, we have to adjust for that, and I did not. So I'm going to do that now. If it is 46 minutes past the hour, that means this hour hand has shifted to get closer to the 2. Okay, so don't do what I did. Make sure you adjust for the hour. If you're using your number line clock, your Judy clock will do that because of the way it's designed. Now, let's talk about the second part of our problem. I'm going to shift those right there. About what time is it? This is that estimation piece where our students have to estimate to the nearest 15 minutes or the nearest quarter hour. Right? I am going to stand up and show you what I do in my classroom when I get into this with my students. I take my classroom clock and I partition it into 4 equal parts. Your students have learned since 2nd grade how to partition circles and rectangles into 4 equal parts, and they refer to them as quarters. Okay, so 4 parts. I have partitioned it here using an expo marker. It will come off, and partitioned it here, creating quarter parts, 4 equal parts. And each part on my clock represents 15 minutes. Okay, I have labeled my classroom clock shift this down a little bit so that when the minute hand is here, the quarter hour is obviously o'clock. When the minute hand is close to the 3 here, it's about quarter past, so thinking that 15-minute mark. If the minute hand is anywhere in this range between the 5 and the 7, it's about half past the hour. And then if the minute hand is near the 45-minute mark, it is quarter till the next hour. This is very helpful to have on your wall and continue to refer to it as you work through this, okay? So that is something I would definitely do in my classroom, but let's think through real quick what this would look like on our Judy clock. This is the one that's easier to show the partitioning here. So I would do the same thing I did on my classroom clock. I would partition my clock into 4 equal parts from the 60, the 12, down to the middle, and the 3, and the 6, and the 9. And you can have your students label o'clock, quarter past, half past, or quarter till, and help them. But if we go back and look at where our clock was set originally, right there at 1:46 per Mr. Williams's watch, we can clearly see that it is closest to the quarter mark, the 45-minute mark. So we would read this time as it is about quarter till 2. Okay. These fractional parts will help your students identify and estimate that time. Okay. All right. You can find more strategies for IOA 5B in our Analyzing the Standard document for AKS 5. Please go check it out. Hi, third grade teachers. Today we are going to talk through instructional strategies for IOA 5C. IOA 5C requires students to solve meaningful problems involving elapsed time that include intervals, time intervals of hour, half hour, quarter hour, where the times presented are only on the hour, half hour, or quarter hour. Real quick, what this means is when students are given times presented in these meaningful problems, they can only be on the hour, half hour, or the quarter hour. That's it. Now, that means if I think 6 o'clock, 6:30, could be 6:15, could be 6:45, because it is to the quarter hour as well. When those times are presented in these problems, the intervals of time also include the hour, half hour, or the quarter hour, okay? And we are going to talk through some of those problems and what those look like. The other thing in this IOA students are required to discern between the two is AM and PM. Excuse me, AM means before midday, and the times represented throughout that AM period are 12 a.m. to 11:59 a.m. PM means after midday, and the times represented during the PM period of the day include 12 p.m. all the way up to 11:59 p.m. Students will not be crossing from the AM period of time into the PM period of time in any of our situations. They will only solve problems where it is anchored in the AM period or the PM period. Real quick, before we get started, I want to talk to you about the different problem types your students will engage when solving these elapsed time problems. They will be solving for an unknown end time. They will be solving for change of time when students are given both the start and the stop time. They have to find the change of time, and they also have to find the unknown start time. They will be given the stop time and also the change of time, but they have to determine the start time. The progression that is suggested for engaging in those types of problems is finding end times first, then change of times, and then engaging with those start time unknowns. And we are going to jump into one of our problems here. But before we do that, well, let's just go ahead and look at our problem here. This is Carlos's mom started cooking dinner at 6 p.m. and finished cooking 1 hour and 30 minutes later. What time did Carlos's mom finish cooking dinner? Again, have your kids make sense of what's happening in the problem. What math movie do they see? I see a mom starting dinner at 6 p.m. and she cooks for a while, and that amount of time is 1 hour and 30 minutes. And I've got to figure out what time did she stop? Okay. This is what we call an end time problem, where we are finding that unknown end time. We are going to do that with some tools today, and we are going to use our analog clock, our Judy clock here, but I also want to show you a tool that we will be using, and this is a time interval map along with time interval rods. They're a pretty cool tool. The rods are cut into various intervals. This 60 minutes represents 1 whole hour. You can also see try to see here, it is partitioned so that you can see there are 12 increments, 12 sections in 1 hour. You can also see here that I will go back to the 60 minutes, 30 minutes. There are 2 equal parts. Okay. And again, these still are partitioned into those increments of 5. And we also have 15-minute parts, and as well as, I'm just going to show you real quick, 10-minute parts, as well as 5-minute interval rods that we will be using to solve these types of problems. The other cool thing about this, I think, is, again, if you go to what is the 1 whole hour, it helps kids, if you rotate this, helps them see that 30 minutes is also half an hour. Helps them see 15 minutes is also known as a quarter hour. So those are some nuances about the tool, but let's get back into our problem and start thinking this through using the time interval rod. Okay. All right. So we know Carlos's mom started cooking dinner at 6 p.m. Guys, this map is designed so that p.m. is on top of the segmented line and AM is represented on the bottom. This map goes all the way down on the top, all the way to 6 p.m. and then it reoccurs here starting at 6 p.m., 6 a.m. and it continues. I'll just slide it down all the way down until you get to the AM and PM of midnight and noon, as well as the 6 I was telling you about. Okay, just so you know how this works. So let's jump into our problem and how these time interval rods work. I know we are starting at 6 p.m. When I'm working with my kids, I would go ahead and highlight. You can see here how the hours, the line's a little bit longer. I'm going to go ahead and denote that more for my kids and have them place the 1 hour rod. If your students need a reconnection with an hour is 60 minutes, they can certainly do that. You can place it on top of the lines if you choose, or under it. It's entirely up to you. But either way, we end the 60 minutes or our 1 hour ends at 7 p.m. So that was 1 hour. Okay. Then I know Carlos's mom, she cooked an additional 30 minutes. So it was 1 hour and 30 minutes later. I'm going to find my 30-minute interval rod, and I am going to connect it to my hour and mark where this time ends. And it's about right here. So once I've done that, I should be able to identify what time this is. I'm going to slide this off just for ease of purpose. I know ease of writing. My hour took me to 7 p.m. So I know that's 1 hour. Well, now I've got to count here. If your students already know that we know that's 30 minutes, right? just going to use an N for minutes. And your students may, at the point in their learning progression for time and telling time, they may have to count by 5 minutes, and that's okay. We just need to know that this is 7 p.m., which I kind of covered up with my expo marker, but you can still see it right there. And I'm going to count each increment: 7:05, 7:10, 7:15, 7:20, 7:25, 7:30. So the time that Carlos's mom finished cooking is 7:30 p.m. Okay. All right. And I need to put my abbreviations there. Just so you know, you can also represent p.m. lowercase with the periods there, as well as capital letters p.m. and no periods. The choice is up to you, but your kids will see it both ways. Then I would also go back and make the connection to my Judy clock with my students as well and say, you know what? Let's see if we get the same time. I know we started at 6 p.m., so I have my clock set at 6 p.m. I know Carlos's mom cooked 1 hour and 30 minutes. I'm going to chunk that into an hour and then work with the minutes. And teachers, that is what's most helpful for your students, by chunking the units of time. So I'm going to deal with the hour first. I know an hour is 60 minutes, and I know it's a full rotation around. Again, let me start back. Your kids can also count by fives: 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. 60 minutes is a full hour. I've landed on 7 o'clock, and now I know I need to adjust for my minutes. So she cooked 30 minutes longer. So we can count by 5. Or again, as your students' thinking becomes more sophisticated, they may just shift the clock to 7:30. But if not, and we know an hour has passed, we're at 7 o'clock, we can skip count by 5s: 5, 10, 15, 20, 25, 30. Again, we landed at 7:30 p.m. Okay. So, and have a discussion with your kids. Would it make sense for your mom to cook dinner at 7:30 a.m.? Keep having those conversations with your students about making sense of a.m. and p.m. Okay, let's take a look at another problem type. This problem type is known as the change of time that is unknown. It's that elapsed time, the time that's changed between a start and a stop time. This problem is Carlos's mom started cooking dinner at 6:30 p.m. and finished cooking at 7:15 p.m. How long did Carlos's mom cook dinner? I do want to go back and highlight for you, again, making a point about times presented in our real world problems are only on the hour, half hour, and quarter hour. In our previous problem we just solved with Carlos, his mom cooking dinner at 6 p.m. and cooking for an hour and a half. All of these times in these problems are either on the hour, half hour, or the quarter hour. And here it happens to be on the half hour as well as the quarter hour. All right, so using our tool, we solved the first problem, finding our end time, the unknown end time, concretely. We are going to shift and make a connection to that representational phase where students take the time using the time intervals to using a true number line. All right. So real quick, in order to use this tool to solve this problem, your students will have to identify where the start and the stop times are. So his mom started cooking dinner at 6:30 p.m. Going to find 6:30 on my mat or find 6 on my mat and count until I get to 6:30. So I know this longer line is 6. So 5, 10, 15, 20, 25, 30. That means this increment right here is 6:30. Okay, so I've got that labeled. And then I know his mom finished cooking at 7:15 p.m. So I'm just going to go ahead and find 7, just like we do on an analog clock. Find that hour first and then deal with the minutes and count for each box a group of 5. 5, 10, 15. And this is where 7:15 would be. And we are dealing with PM, the PM period of the day, past midday. Okay. All right. So we know our start time. We know our stop time. We just have to find the change of time. How much time has elapsed or changed? Some students may need to truly count by fives, and they can lay down their, let me just do this, their block of time, their 5 minutes, 5, 10, 15, 20, 25, 30. Talk to your kids about finding the next friendly hour. How can you get there quickly? Some kids may need to count by fives to do this. Some kids can count by 20 as their thinking with time becomes more sophisticated, or some students may be able to say, you know what? I know 30 and 30 makes 60, so I'm already at 6:30. 30 more minutes means I'm at 7, and now I just have to figure out how much time is between 7 and 7:15. Again, your students can count individually, 5, 10, 15. Put these together and connect, and then count the total. I can keep that straight. So they have, Carlos's mom has cooked dinner 30, 35, 40, 45 minutes. So that change of time between 6:30 and 7:15 p.m. is 45 minutes. Okay, now we're going to take this thinking and transition it to that number line. I'm going to slide this up. Actually, I'm just going to slide it right there and try to work from here. Right there. Right, and I'm going to grab a marker real quick and think this through with you. So to make the connection from our time interval rods to an open number line, we are going to do the same thing we did here. We are going to draw an open number line. Now we are going to label it with our start time. We know his mom started cooking dinner at 6:30 p.m. We also know she finished cooking dinner at 7:15 p.m. Okay. Now we just have to count until we get to 7:15 in those increments of time, counting by fives, counting by tens. Again, help your kids reason through, well, how can we get to our next friendly hour? Okay, and I got misplaced. Here it is. I know that I could count by fives if I needed to, and count 6:35, 6:40, 6:45, 6:50, 6:55, 7 o'clock. I also know, and that would be increments of 5 minutes. I also know if your kids could count by tens, but more efficiently, I would want my kids to recognize as quick as they can that I know I can jump 30 minutes and get to 7 o'clock, and then I can figure out the remaining amount of time. We can still count by fives, 5, 10, 15, 5, 10, 15, and that entire chunk is 15 minutes, right? We know we can now count up the number of hops. We can count all the fives if we choose, or we can count at 30 and 15, and we get a total of 45 minutes is how long Carlos's mom cooked dinner. Okay, let's take a look at our last elapsed time problem type. This is a start time unknown problem, and this tends to be the most challenging for students. Again, as you are working with these time intervals, always chunk your units of time into hours and minutes and deal and work through the problem that way. Let's go ahead and talk this through real quick. And we started with the concrete using our time interval rods as well as our analog clock. We transitioned to the number line, the representational phase, using the number line, and we're going to stay here with with this type of problem as well in that representational phase using the number line. So thinking through this problem, Carlos's mom cooked dinner for 1 hour and 15 minutes. So we know how long she cooked dinner. She finished cooking at 7:45. Okay, 7:45 p.m. So those are the two things we do know. She stopped cooking at 7:45 p.m., but before that, she cooked for 1 hour and 15 minutes. So what we have to figure out is what time did she start cooking? To do that, I'm going to use an open number line. And again, if your students still need to go back and use the time interval rods, find and label the end time as being 7:45 on that mat that is with your kid. Okay. Then we're going to work backwards, and I'm going to chunk this in by units of time. I'm going to deal with my hour first. Okay. Or you don't have to always do hours first. You could work backwards and deal with the 15 first if you wanted to, and count it back 15 minutes. The choice is up to you. Either way, just chunk your units of time. So I'm going to start with just the hours. And I know 1 hour before 7:45 p.m. is 6:45 p.m. because only the hour is changing, not the minutes yet. We're not dealing with the minutes. So I'm going to jump back 1 full hour. And I'm going to label this time as being 6:45 p.m. Okay. Again, the only unit of time that's changed are my hours. Okay. But now I've got to deal with my 15 minutes. So I've got to count back 15 minutes. Again, if your students need to count back by fives, absolutely fine. If they recognize they can make a jump of 15 and they know that next quarter hour is 30, awesome. But for our purpose, I'm going to jump back by fives and count back a total of 15 minutes. So there's a jump of 5 minutes, and that takes me, I'm going backwards, to 6:40 p.m. Another jump of 5 minutes, and backwards, it brings me to 6:35 p.m. And another group of 5 takes me to 6:30. And yep, that amount of time was 15 minutes. And I know Carlos's mom started cooking dinner at 6:30 p.m. Okay. You can also scaffold your students with an analog clock if they need a more visual piece to connect with. Again, find the stop time. That's what you label on your clock first, and then we work backwards using our intervals of time, the 1 hour and the 15 minutes. Again, going back to what I know 1 hour before 7:45 p.m. is 6:45 p.m. If your students need to count backwards by 5, that's fine as well. And until they get to 60, I am going to just scoot all the way back here until we get to 6:45. And then I'm going to jump back 5 minutes until I reach 15. So I'm going to start with my minute hand here. There's 5 minutes, 10 minutes, and 15 minutes. We also proved here on the analog clock that we landed at 6:30 p.m. Again, if your analog clock is a great tool to scaffold their thinking, if they are still in that concrete phase of learning with this particular IOA. Okay. You can find more instructional strategies for IOA 5C in our Analyzing the Standards document. So which strategy? In mathematics, the emphasis is on the reasoning and thinking about the quantities within mathematical contexts. Specific mathematical strategies for teaching and learning are not mandated by the Georgia Department of Education, nor will they be assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable for and make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards preserve and affirm local control and flexibility. This is from the Georgia DOE's Comprehensive Grade Level Overview.